Welcome to Brain Vision.
A billiard ball of given mass is moving at a given speed when it strikes two sides of a pool table as shown in the diagram. It first strikes side A and then B at the shown angles with the given velocities. Now we know the coefficient of restitution between the ball and the side of the table. We want to determine the speed of the ball after striking the table twice. So that is at point A and then at point B. So we've labeled everything before the impact at A with subscript 1, after the impact with A with subscript 2, and after the impact with B with subscript 3. So firstly, we will look at point A on the pool table. Now, we've chosen our axes as follows, X and Y directions. So our velocity at A, the Y component at least, VAY, subscript 1, is equal to the initial velocity which we're given, 2.5 meters per second, times sine of 45 degrees. And so this is 1.7678 meters per second. Now the coefficient of restitution, E, is equal to, this is at A, remember, VAY after the collision with A, and VAY1. This is before the collision at A. So we are given this coefficient of restitution, which is 0.6, and we have one of the velocities. So this is VAY2 over VAY1. Actually, VAY1 we have calculated already, so if we substitute that in, that's 1.7678. And so if we rearrange this equation, we get that the Y component of the billiard ball's velocity after it strikes point A is 1.061 meters per second to the left as we draw our diagram. Now the X component, VAX, after the collision is equal to the same as it is before the collision, VAX1, and this is 2.5 times the cosine of 45 degrees, which is 1.7678 meters per second, but that's downwards. So that's at point A at the pool table. Now at position B, we'll do the same. So at position B, the coefficient of restitution E is equal to VBX3 after it collides at point B over VBX2 before its collision at that point. And so again, we know this coefficient of restitution is 0.6. 0.6 is equal to VBX3, the X component of the final velocity of the billiard ball, over 1.7678. And so again, if we rearrange this, we get VBX3 to be 1.061 meters per second. So the final X component of the billiard ball after making two collisions is 1.061 meters per second. Now we need the Y component, but the final y component, VBY3, is the same as VAY2. So after colliding with A and moving towards point B. And this is 1.061 meters per second. So we've calculated this already. So hence we can now find, since we have VBX3 and VBY3, the x and y components of the final velocity, we can calculate the final speed of the billiard ball after making two collisions. VB3 is simply the square root of the sum of squares of each of these components. So that's the square root of 1.061 squared plus 1.061 squared. And so we get the final speed of the billiard ball to be 1.5 meters per second.